Each one of the trig ratios that you've used before, sine, cosine, and tan, has a reciprocal function. So the reciprocal of anything is 1 over that thing. So for example, reciprocal of x is 1 over x. Reciprocal of tan is 1 over tan. Reciprocal of cosine is 1 over cosine. Okay, but obviously has specific names. So for example, cosine x reciprocal is 1 over cosine, and it's called sec x. So it's a new trig ratio that you're learning this year. Sine x is 1 over sine x, and it's called cosec. And the other one, well, I'll write the full word of the cosec is better. Cosec. And the tan reciprocal was 1 over tan, and it's called cot x. Now you notice cosine C, and you will see the third letter is C as well. Sine, that's the third letter. Sorry, that's the third letter. I'm just used to writing the shortcut for that. Okay, the third letter. And the tan, the third letter. So it's always the third letter is the same as that one. You remember. Or for the second cosec, I always remember choosing the opposites letter. Like, you know how sine start with S, cosine start with C. So for the cosines, the reciprocal for the cosine will be sec, opposite. Reciprocal for the sine will be cosec, you know, the C. So whichever you would like to remember. Now we use these reciprocal functions. Obviously we'll use them a lot in differentiation integration, but we use them for this trig to prove trig identities. A trig identity is identities are like facts. They are always true. So to prove them means they are not equations. So you don't rearrange between left and right hand side. Proving a trig identities is you either working on the left hand side and simplifying to get the right hand side, or you start with the right hand side and simplify to get the left hand side, or you simplify both sides separately until you get same answers on both sides. So we're going to do a lot of trig identities in this for this week. Okay, so before we can start proving trig identities, there are, so when in the formula sheet, in your calculus 3 formula sheet, you have a page that full of trig identities. Those identities are facts, so you will use them as they are. So for example, the first there will be 3 identities we're going to cover in this video. So the first one is sine square x plus cosine square x equal, we use 3 lines for equal for identities, equal 1. Means wherever in your practice you see sine squared plus cosine squared, you can reduce those 2 terms into 1. Okay, so you just replace them or substitute them in 1. The other identity that you're going to use is tan square to x plus 1 equal sec square x. Okay, so that's another identity. The third identity that we're gonna work on today, cot square x equal cosec square x. Okay, so whenever you can see tan square x plus 1, you can replace it with sec square. That's what we call a method of reducing. Reducing means instead of 2 terms, I'm going to substitute it within 1 term. Okay, you can rearrange in here. So for example, this is the same as if I see tan square x minus sec square x equal 1. So I can replace it with 1. Right, so and it's the same here. If I have 1 minus cos x square x, I can substitute it with sine square. So these are the different ways that you can use those identities. Now, how to prove this identities? So how we know these true? If anyone interested, I can go take you through it. You don't need it. These are entities are given, and you're going to use them. And we're not doing the trig standard. We're only going to study the trig identities because we need them in differentiation and integration. Anyway, so we're just going to go over before I start doing examples. There are a few tips that helps you to simplify trig identities. The first tip, or to prove first identities, the first tip or the first rule, what we call reduce. Whenever you have when you have the expression that you've been given, you're trying to reduce it to sine and cosine. X means if you have tan, sometimes you have to expand the tan into, you rewrite it as sine over cosine, and then you will have to simplify and things to reduce it to sine and cosine. This is a good thing to keep in mind because most of the time when you're trying to, like, you can rewrite. For example, if you want to get sec, then you will try to get 1 over cosine. Okay, so doesn't matter how complicated this your expression you will be given, you're trying to convert everything to sine and cosine because that will allow you to simplifying later on. Another tip you could use is fractions. If you have fractions, if the expression has fractions, try to make all the denominators for all the fractions, so common denominators, for all the fractions the same, so you can reduce, so you can add or subtract. So to add or subtract, okay, to convert them from multiple fractions into 1 fraction. Another tip you could use, or another rule, is splitting the fraction. Split fractions. So those are the skills you can use. Obviously, each skill you will decide where to use them depending on the questions, but those are the main ones that you keep them in mind. So split fractions means, for example, if I have cosine over cot, I'm just going to write it in a different color so you can see. If I have cosine x over cot x, I can split that fraction. Instead of I leave the cosine here, and cosine, and the cot I can write it as 1 over cot x, and obviously that can be taken further. Look, that cot 1 over cot x can be written, obviously cot x is 1 over tan, so obviously by 1 over cot is reflecting that, like, you know, fractions, so that 1 over cot is the same as tan x, and then tan x is 1 over sine over cosine. And you can see now I can simplify those two. So look at the answer is sine x. So I started with cosine over cot, which is way more complicated than sine x. It's all by splitting the fraction. There's just examples of different methods you can use. If you have powers, remember factorization. Factorize to reduce powers. That's a method you could use. What else? Yeah, we've talked about, okay, use trig identities. We've spoke about using the trig identities, that one we just discussed in the previous slide. Use them to reduce the terms. And then by practice a lot, the more questions you get is the best. So I'm just going to write reduce. Hopefully you remember. Reduce using trig identities. Hopefully you remember what I mean by that. Okay, so now, so the examples that we're going to work on. So for example, if you've got this identity, tan cosec square x minus cot x sine square x equal 0. You want to prove that identity. So as we said, proving an identity is not rearranging. So you can't say tan x cosine square x equal cot x sine square x. It doesn't work like that. You don't rearrange. You must start with one side. You either start with left hand side or right hand side, whichever is more complicated to simplify it. So obviously you can tell that the left hand side is more complicated than the right hand side. The right hand side there's 0, so you can't do anything with the 0. So you're trying now to use your trig identities to simplify. Now you can see that I've got cosine square here, sine square here, and I've got tan and cot. So obviously by expanding, remember the first rule we spoke about, changing everything to sine and cosine. Okay, trying to reduce to sine and cosine, and I can do that because I know tan is sine over cosine. Cot is the reciprocal of tan, so it will be cosine over sine, so the opposite. Okay, so we're going to start now. So I'm going to write that tan as sine x over cosine x. Obviously I haven't done anything with the cosine square, so I'm going to rewrite it. Cot, I'm going to write it as it's the reverse of that, so it will be cosine x over sine x, and here I'm going to write as sine square x. And then it's always with trig identity, it's good to continue vertically. So I'm not continuing this way, I'm going to continue vertically. I'm not going to continue horizontally, sorry, I'm going to continue vertically. So next is simplifying. So I've got this with one of that will be simplifying, and I've got this sign with one of that sign will be simplifying. So now rewriting, so I've got sine x cosine x left minus cosine x sine x, and obviously any term minusing exactly the same term is equal to 0, and then you just say proven. That's it. Okay, we'll take another example, maybe a little bit harder. So cosine x equal tan x, and that's equal 1 over sine square x over, I'm going to use the, sorry, I'm going to do 2 because that's not a given identity, you need to prove it, sine x. So now you can start with either way. So you can either start with the left hand side and right hand side. Obviously you always try to start with the most complicated side. So that you can see this cosine x over tan x is way simpler than 1 minus sine square x over sine x. So I'm going to start with the right hand side this time and try to simplify it. Now simplifying this, because I have cosine in here, then I try to get a cosine in here, and the only way you can get a cosine in here is by replacing sine square x using the identities cosine square x plus sine square x equal 1. So I'm just going to write the identity that I'm going to use in here. So that's the identity that I'm going to use. Rearranging this identity means sine square can be written as 1 minus cosine square. Okay, so I'm going to replace that 1 minus, open bracket, and instead of sine squared, I'm going to write 1 minus cosine square x over sine x. So now I can expand and simplify. Obviously this goes, so I left with cosine square x over sine x. Now, then you'll say, okay, that's nothing to do with this one. Well, I need to rework with this side as well to try to get to here, to sine and cosine. So I want it, because this side only has sine and cosine, so I'm going to change this into sine and cosine as well. So hopefully I'll get the same thing. Then cosine, I can't change it. The tan can be written as sine x over cosine x. And that can be written as cosine x, changing the division into multiplication, flipping the denominator. Now that comes into cosine square x over sine x, and look, it's the same, so proven. Okay. Okay, we'll do the third cosine. I'm going to use theta this time. It's just easier than writing the brackets. You can still not write brackets, but it's just my handwriting sometimes. This is annoying. Okay, so we're going to try to choose one of the side as we see it. To simplify it, we use the most complicated side, and obviously this time is the left hand side. Okay, so because of the right hand side has sine, so I'm going to try to rewrite the right hand side, the left hand side in sines only. Okay, so working on this. Okay, I'm gonna just put a line here. So because we've got the left, as we said, we've got the right hand side has sine, so we're trying to open this one up to sine. It's easier, and then simplify. So we've got cosine theta over sec theta is 1 over cosine minus sine tan is 1 over sine over cosine. So these are obviously common denominators, so it will be 1 minus cosine, and then you can flip it, take the reciprocal, change it to multiplication. Okay, I'm gonna do it actually better than explaining it. 1 minus, and then now I'm gonna continue here. So we've got cosine theta, changing to multiplication will be cosine theta 1 over 1 minus sine theta, just the fractions, and that's why we end up with cosine square theta over 1 minus sine theta. Okay, and now because I've got cosine theta, there is no cosine on the right hand side, so I'm gonna open up the cosine using cosine square plus sine square equal 1. So that identity, so I'm gonna re-substitute, instead of cosine square, I'm gonna do 1 minus sine square. 1 sine square theta over 1 minus sine square. And then 1 minus sine square theta, now we want to reduce the power. There is no common factor, so you'll have to think of factorization. This is the difference between two squares, so you can factorize the numerator as 1 minus sine theta times 1 plus sine theta. That's over 1 minus sine theta. Now you can simplify the common factors. So those two simplify, and you end up with 1 plus sine theta. and that's proven. Thank you.